Hi everyone, welcome back to Calculus with Jackie and Shadow. Today we're going to be talking about infinite limits and vertical asymptotes, how those relate to each other. So let's get started. So if a function approaches infinity, it can be positive or negative infinity at some value a, then that means there's a vertical asymptote at x equals a. And that makes sense because if you have a function that's increasing without bound in the positive or negative direction as you get closer to a point, then that's the definition of what a vertical asymptote is. And this can be useful if you want to sketch a graph when you have limit values. So let's try this problem. So Jackie and Shadow are flying on a path that is the graph of the function f of x. Jackie starts at x equals -10 and flies from left to right, and Shadow starts on x equals 10 and flies right to left. As they get closer to x equals 1, Jackie flies up with that bound, and Shadow dives down with that bound. Now I want to find the limit as x approaches 1 from the right, the limit as x approaches 1 from the left, and the two-sided limit. So if we think about this, it says that Jackie starts at -10. So Jackie's going to be coming in from the left and going right. So that's going to be our limit from the left. And the limit from the left, it says that Jackie is flying up. So the limit from the left is going to be infinity. And Shadow's flying from the right. He's going down. So his limit's going to be negative infinity. That's the limit from the right. Now let's look at the graph of this, because it asks us to sketch a graph. So let's try to graph this. So Jackie's going to start right here, and Shadow's going to start right here. So Jackie's going to fly like this, and getting close to 1, we just go up, and we're approaching infinity. And then it can be anything, this path right here. But as we're getting closer to 1, Shadow's going downward. So going off to negative infinity. We're going to draw that right there. And that's our vertical asymptote in the graph. So that's what the graph's going to look like. Now let's try something a little harder. So a function f of x has the following properties. The limit as x approaches 5 from the left is negative infinity, and the limit from the right is infinity. Now, the limit as x approaches 3 from the left is infinity, and from the right, it's negative infinity. And finally, for the limit as x approaches 1 from the left, that's infinity, and 1 from the right is also infinity. So first, we're going to sketch a graph of this function. Now, what would a graph of this look like? Well, let's go over to the calculator. So let's start with drawing where the vertical asymptotes are going to be. So because the limit goes to infinity at these points, we're going to have vertical asymptotes at x equals 5, x equals 3, and x equals 1. Now, from the right, it says that this limit is infinity. It's positive infinity. So we're going to go up towards positive infinity. And then from the left, it's negative infinity. So we're going down towards negative infinity. Now for 3, it's the opposite. From the right, it's going to negative infinity. So we're going down. And then from the left, it's positive infinity. So we're going up. And then finally, for x equals 1, x is getting closer to 1, It's approaching positive infinity from both sides. So we're going to have something like that. And that's a possible graph. Now the second thing is f of x is defined as 1 divided by g of x, which is a polynomial. We want to find a possible factored form of g of x. And this is a little challenging. So let's think about what the difference between 1 over x and 1 over x squared is. For 1 over x, it's going to positive infinity from one side, negative infinity from the other. And 1 over x squared, it's going towards the same direction from both sides. So both sides is going to positive infinity. Now for our function 1 over g of x, we want g of x as a factored polynomial. So we can use the zeros of the polynomial to factor it, because we know that it's going to have a vertical asymptote when it's 0. So we'll just have the zeros of the polynomial as 5, 3, and 1. So that means the polynomial is going to be something of the form x minus 5 times x minus 3 times x minus 1. But then this isn't quite right, because this is just approaching 1, and you can see it's positive from this side and negative from this side, and we want it to have the same sign on both sides. We want it to be positive on both sides. So we need to do x minus 1 squared. And you can see that if we take this polynomial and we take the reciprocal 1 over that polynomial, it perfectly matches f of x. So that's it for today, and I'll see you next time.